Uh, Hi, here we have a GCSE question on circle theorems. Now, a lot of the marks could be lost here by actually not giving a reason, so we've got to be very careful that after each angle that we work out, we write down the reason why it is that particular angle. So I'm going to start off with the isosceles triangle ABD. The base angles in an isosceles triangle are equal. So if I just do 180 take 40, which gives me 140, and then I half 140, which is 70, of course, I get these base angles. Okay, so I'm going to write that down. The reason base angles in an isosceles triangle are equal. I mean, what we worked out there is BAD, and we've also worked out BDA. I mean, BDA is going to be we're going to use both the angles actually to work out the final answer, which is ADE. ADE, of course, is this angle here. It's the central letter when you quote the three angles. If I just go through the diagram, ADE is what we're trying to work out, is this angle here. Now, the next angle I'm going to add to the diagram is 110 here. And that is because we've got a cyclic quadrilateral. So I'm going to write down that ABCD is a cyclic quadrilateral. And in a cyclic quadrilateral, opposite angles add up to 180 degrees. I think for a bit of consistency, I'm going to write down that triangle ABD is isosceles. Now, triangle BCD is also isosceles. So we'll just extend the page here. Triangle BCD is isosceles. So I'm going to do 180 take 110 this time, which equals 70. And again, I'm going to half to get these base angles. And 70 divided by 2 is 35. So these angles here are 35 and 35. And finally, the angle we're looking for is the third angle on a straight line. I know the diagrams now become quite complicated, but you can see that 3570 and this angle here, which is called angle ADE. So ADE is equal to 180 take 70 take 35, which equals 180 take 105, which equals 75 degrees. And again, not forgetting to state our answer, which is angles on a straight line I'll just extend that page again. Add up to 180 degrees. And there's my answer there. course, one of the remarkable things about a smartboard is some of these fancy tools. We've got a magic pen here, which might just help us isolate the straight line there. You see, there's a straight line, and there's a 3570 and the missing angle on that straight line, which is the bit that sometimes pupils get confused with. Okay, that's all done.